Now's a
Yeah,
good time?
we can
Okay.
go ahead and get started. All right, so my name is Colleen Heineman. I am one of the facilitators for our webinar series, and I'll be helping you guys out for this webinar with Wendy, who's also on the call right now. We're very thankful that you guys came, so thank you for coming to part one of two parts of a Python introduction webinar series. We're very excited to have Blake Lohn-Wiley, with us to present our webinar. Very qualified, very excited to be here with you guys. So I'm gonna let him introduce himself and go over some logistics and then go ahead and kick off Python for beginners. So Blake, whenever you're ready.
All right, guys, thank you very much for coming. Just a little bit about me. I have an undergraduate in pure mathematics, and then I have a master's in applied mathematics. And I've had the opportunity to conduct research in a lot of different fields. And as a result, it's given me a lot of very in-depth background in a lot of different topics. And I've been very fortunate to do that. This is, some of those are my hobbies, and yeah, that's me actually climbing. It's not a image I found off the internet. That would have been a good idea though. And then some of my previous experiences, I have worked at NASA. I worked for NASA while I was a graduate student, providing them support remotely as a software engineer. And then I've also competed in a lot of different interdisciplinary competitions that require teamwork. I did a lot of programming for them. And then for the past 2.5 years, I was at Oak Ridge National Lab, and I fortunately got to work on 3 different projects. And they ranged from they were as complete opposite as you could get. And I am now currently in Denver, Colorado, and I currently work for a company called Secure Set Academy, and we train people in cybersecurity. So with that being said, let's get started. So the takeaways, what I hope for everyone to take away today are just a very basic understanding of how Python works. If there would be any consolation, if there was anything that you took away from this, was the ability to have enough of an in-depth understanding to at least assign a couple of variables and do a couple hello print world statements, things like that. The way that this is designed is that as this presentation is going on, it's been broken down into 3 sections. And I plan on covering each section in roughly about 15 minutes with like a 5-minute break. And as I'm covering it, the reason you're probably wondering why that the login information was provided for you. Well, what you're looking at right there is it's called Juniper Notebook, and it allows you to execute Python code within a web browser. And, since the target of this audience was more for beginners, I didn't want anybody to have to really worry about having to install Python, and feel like they were going to miss out. So that web browser actually is an instance of Python. And how this is laid out is that as I go through the section and talk, you'll see that notebook is designed that way as well. So as I'm talking about data types, data structures, functions, classes, things like that, you'll see little headers in the browser that is exactly Python code. Now what you're looking at in there is you'll see those boxes that say in with the square brackets, in square brackets. What's going on is you can think about those little blocks as functions, right? You have an input and then it sends out an output. And so I thought that was also a really unique way to visualize and see, oh, okay, hey, this is a chunk of Python code. This is the output. And what's even better though is you guys, as we're going through this, can change anything in those boxes. And please feel free to do it. If there are 2 ways to actually execute the code. One is if your cursor is in the actual box, if you do Shift Enter, that will execute the code, and then you should see the output directly below that. There's another way is if your cursor is in the box and then you see a little play button from the menu, that play button will execute that specific box. So with that being said, let's get started. So in Python, you have a range of varying data types, everything ranging from numeric types, sequences, sets, and mappings. Some of them are mutable and some of them are immutable. What mutable means is that when they're declared and the elements inside of them, they can be changed. Immutable means that once you have a function or variable declared with elements contained within it, you can't change it. So so if we go to section 1, if you look on the Juniper notebook, you should see a section titled data types, and you should see, like maybe some code or a block of code that says, this is a integer, this is a float, Boolean, complex numbers, and such. And one of the great advantages of Python is it's very easy to understand. When they originally wrote the language, it was meant to be like you're reading a sentence. It's structured in such a way, and it has that amount of flexibility that it's able to do that. So if we're talking about, I don't want to assume that everybody knows what each one of these things is. But so integers are basically any numbers ranging from negative infinity to positive infinity, and they're whole numbers. Floats are floating point numbers. You can think of them as decimals, or how your bank account statement. And then complex numbers are a mixture of real and imaginary numbers that are heavily used in different domains such as quantum mechanics, physics, astronomy, energy research. So one of the other great things, again, and this is why I thoroughly enjoy Python, is if you see how it, underneath where it says string, and you see the single quote or the double quotation marks, that right there is if you were to copy and paste that or type that exact string within one of those boxes and then hit shift enter, that is how you pass a string onto the Python interpreter. Now, there are 3 ways to define a string within Python. One is using the double quotation marks, the other way is single quotation marks, and then triple quotation marks. And if you look under lists, that right there is lists are defined by square brackets. And then the elements or objects contained in those lists are separated by a comma. And then tuples, so the way that I think about tuples, the difference between tuples and lists, is that, remember how I referenced earlier mutable and immutable types? Well, lists are mutable. So that means that if you copied and pasted, you said x equals those square brackets, let's say element 1, comma 2.4, comma true, you could access any one of those elements via the index. And the index in Python starts at 0. So I got a little bit ahead of myself with this. So what we're looking at here is sequences. And sequences are just basically a series of elements that are delimited by a comma within Python. And the index values range from 0 to n-1. So think about it, as n is the number of elements or the number of objects or classes contained within a list, a tuple, or a string. There we go. Got the mouse back. So if you look, you can see that basically sequences are a ordered collection of elements. You can store a sequence of elements in a list. The elements can be of varying types, consisting of a list that contains elements data. So what that means is you can nest different data types within a list. So I mean, if you wanted to, you could have a list that is nested, or there's basically being 99 lists within a list. Think about it as like the Russian doll. What is that word? not synonym. If you look at, if you were to Google Russian nesting dolls, that picture right there, all into itself, essentially is the premise between when you hear something is nested. It's just you're able to put something in something. So the elements can be of varying types, consisting of a list that contains elements of a data type, integer, float, complex, and Boolean. A list is denoted by the use of square brackets. It's a starting square bracket and an ending bracket, with each element being separated by a comma, with each element, being separated by a comma. But another way to think about it is, or another concept to think about is a list. It just contains different data types: floats, integers, Boolean, lists, strings. And again, I mentioned that lists are mutable data structures, meaning that you can, once they are assigned values, you can change them by accessing them by the index. So if you look at the Python or the Jupyter notebook, you should see a section titled sequences. And if you go there, you notice that if you hit Shift Enter, you're gonna, I don't have it in front of me right now. But you'll notice that if you were to say X equals in front of any one of those lists, you could access the elements within that list by using the index. So if your list is defined as X equals, then the elements within that list, denoted by the square brackets, you could say X square bracket 0 in square brackets, and then hit enter. And what that's going to do is it's going to output the first element in that list, X. And the nice thing about it is that anytime that you input or append to the list, in whatever ordered elements are added, that's how they're accessed. So you don't have to worry about the order is conserved. Now, getting on to strings. Strings are just a list, but instead of it, well, that's not a list. I'm sorry, that's incorrect. A string is just an array of characters. And if you were to say X equals this is a string, you can then access the individual elements or the characters that make up that string by using the index. And again, that starts at 0. So if, we said str is equal to this is a string inside double quotation marks, we could then access, the first character T by saying str square brackets 0 in square brackets, and then hit Shift Enter, and then it would display the first letter, which would be T. So now getting on to tuples. Tuples is very similar to that of lists, except the key distinguishing factor is that tuples are not, they're immutable data types. So when you put elements inside of them, and if we were to say, X equals circle parentheses Python penguin elephant, and we tried to, going back to lists, I'm sorry. If you wanted to redefine an element within a list that you've already established, going back to that earlier example of X equaling the first bullet point list, you could replace the first element in it by going X, by referring to the 0 index. All you would have to do is say X square brackets 0 square brackets is equal to the new element that you want it to replace. And it would then do that. And then if you hit X again and then enter, you'd see the updated element within it. Now getting back to tuples, tuple is a sequence that holds an order of a collection of elements. You can store a sequence of elements in a tuple that contain different data types. Again, just like a list. A tuple is denoted by the use of round brackets, a starting round bracket and an ending round bracket, with the elements being separated by a comma. And again, tuples are unchangeable, they're immutable when elements are assigned to a tuple. So the next one, and probably my favorite data structure within Python, is the dictionary. It is one of the most versatile data structures within all of Python. Oh, I'm talking about sets. I'm sorry, I got a little ahead of myself. So sets are denoted by curly brackets, such that there's a starting curly bracket and an ending curly bracket, and the elements are separated by a comma. Um, there are two key differences between sets and lists and tuples. Sets are just like lists, except they are unordered. So that means that if you define a set and you say, and if you say as x equals apple, the first bullet point under that set, and then if you hit shift enter, it's not always going to spit out the same order as it looks there. It wouldn't be, the arrangement of the elements would not be apple, orange, grape, mango. So every time that you submit to the Python interpreter, x equals that first bullet point, each time the arrangement or the order of those elements is going to be different. And another distinct value about sets is that, let's say, it was apple, orange, grape, mango, apple, right? Well, one of the unique features about sets is it only keeps unique values in there. So that means if there's any duplicates, before it even gets to the output on the console, any duplicate or additional elements that are copies are removed for you automatically. And that's the same thing with strings, floating point integers, other lists that are contained within there. Every element is contained within a set is unique. And again, sets are unordered. So the difference between sets and frozen sets is that, again, this is sets are mutable objects, or sets are mutable object types. The frozen sets are not. So remember when I referenced the difference between lists and tuples? It's the same thing, the same difference between sets and frozen sets. So if you define a set, you can replace or modify elements with already in it by accessing that element through the index. With the frozen set, you can't. Once it's defined, it's defined and stuck like that. And they're denoted by the same methodology that sets are. Is it not? Okay. So like I said, this is my favorite data structure within Python because it's so versatile, and it, to me, is one of the easiest concepts to understand. A dictionary is like an address book where you find the address or contact details of a person by knowing only his or her name, i.e. we associate keys, his name, and then the value, his details. So the main way that dictionaries operate is they have keys and elements or values. So if you see underneath there where it says in parentheses key -1 semicolon, in parentheses value 1, that means that if you define that dictionary exactly as it is minus the in, so let's say it would be x equals key 1 value 1 key 2 value 2, you could access those elements, you could access value 1 in a multitude of ways. You could say x square brackets, then the name of the key associated with value 1. So it would be x square brackets key -1 in bracket, and then it would return in the command line value -1. And the nice thing, or keep in mind though, that with keys they must be unique, and there can't be any duplicates. Now you can have nested dictionaries, and you can have certain dictionaries where keys hold or reference to multiple values, but that's beyond the scope of this presentation. Yeah. So let's see. So Now, when I was talking now, variables are what basically allows you to reference an object after it's been assigned. So when I was referring to x equals xyz, or x equals square brackets and then some strings separated by commas in brackets, I could then basically, that's what variables are, what allow you to reference or store that information within RAM of the computer. And you assign them just like you would when you, as easy as x equals 2 or x equals, list with elements contained within it. Now that concludes the first part. I'm gonna take a 5-minute break and then I'm gonna start on the second section. So if at this point you have any questions or having issues with the website or not being able to access it, please shoot a message in the box or speak up and we'll try to get you access to it.
Hi, Blake. It looks like we have a question.
Yes.
Could you remind the audience how to access? What is their sign-in?
Okay, so their username is their first name in all lowercase letters. And then the password is just password.
It looks like we have one user who's still not able to get access.
Is his name Steve?
Looks like it's from Danielle.
Danielle? Danielle, if you could just remove the H in your web browser, just remove the HTT, basically everything to the left of EC2, just delete and then hit enter or refresh the page. And that should allow you to log in.
And then while we're waiting to see if there's any other questions, if I could just remind the audience to please go ahead and mute your microphones so we don't get any feedback for the rest of the audience. And then it looks like Steve still is having some trouble.
Well, if he's did Danielle respond?
It says, for Danielle, invalid username password.
In that case, then try the username out. If not, I can make her another account real quick.
And someone can also use my login if that would work.
That would work too. I'm trying to think. I don't know if it's the same server with the same configurations.
Oh.
Let's see. You can still see the presentation, right?
Yes.
Okay. So Danielle was having issues. Let's see here. Danielle. Okay, Danielle, try now with your username. That should work because I deleted your account and then just added it up, then remade it. Did she say anything?
Not yet. Okay, it looks like Danielle is in, but she sees no files.
Yeah, that's what I was afraid of. Tell her to Danielle, if you could just refresh the page and then you should see the file now. All right, I'm gonna go ahead and start with section 2 now.
Okay, yep, and she's got in. And then just a last minute reminder, in case some of you joined us late, please do mute yourselves. And we'll look forward to the next section from Blake.
Wendy?
Oh, yes, ma'am?
Sorry. It seems that the person from whom we're getting the feedback, from what it looks like to me, is they joined via telephone. Is there some way for them to mute it? Maybe that's the problem, that we're getting the feedback from someone who joined via telephone. I don't know if they can mute it on their telephone unless they have a mute button, but.
That's a very good question. And frankly, I'm not sure.
I checked the participants list and that's what it looked like to me.
Well, hopefully even just this conversation has maybe brought on a change, because it seems already quieter to me. I don't know about you guys.
Yeah, it is.
All right, thanks for that.
All right, well, thank you again. So one of the cornerstones about Python is its versatility with, as you all saw earlier, with its ability to define and structure the data types in such a way. A function is literally, if you can remember back to as early as algebra, where you had your function, you had an input and an output. Well, a function is a simple callable object in Python. And in a couple more slides, you'll learn what an object is. So the naming convention for a function, or basically how you name it, is it should be it should be all lowercase, words separated by underscores, don't use numbers. For more information, there's what's called PEP 8, and that's a style guide for Python code. And I think it's in its 8th or 9th iteration. So there's a lot of documentation on it. That's another great feature of Python, is the open source community and all the documentation that comes along with it. Yes. So if you look, you notice where there's that first statement that says define. And so in the example that we have right now, we are defining, it's called a definitive statement, a definition statement. So we're declaring to Python that this is a function. And that's how Python recognizes that it's a function. When you pass it to the interpreter, it says the def, and it's like, oh, okay, this is a function. I know what this is. So it knows how to handle it. So just like I was referencing earlier, as it being a math, think about it as a very, very simple mathematic function. You have what's called your inputs, or your input parameters. And so in this case, you see how it says A, comma, B. So our input parameters would be A and B in this specific case. So the next thing that happens is if you notice at the end of the parentheses where the inputs are, you'll have that semicolon. That semicolon denotes, okay, that is in fact the end of the function in defining its name. And then if you hit enter, what it automatically is going to do is the cursor will be tabbed over, or 4 spaces. And what that section of the function is known as, is the area where you provide optional documentation. So that's generally when if for your own personal use, and I strongly encourage everyone to do this, is if you ever write your own functions. In Python, there's a nice feature that the first line right underneath after you define that function, you can use a string. And what that first line is known as, it's called the doc string. So that's where you can make yourself a little nifty note about, okay, hey, this is what this function does. And these are the inputs and this is the expected output. And what's really handy is where I showed you that that when you define a string as in triple quotes, the special feature about the triple quote, defining a string as a triple quote, is that you could hit A for 8,000 characters, and since it's a multi-line comment or string, it will keep track of that. Versus if, let's say that you just did a double quote or a triple quote, and you did the same thing but holding down for 50 times and hit print, it's going to cut off at a certain point, versus with the multi-line, that thing will go on forever. So it covered that. So another way, like let's say that if you defined your function, right, you said x is equal to subtract, and then you have your input parameters 3, 2. Another thing about functions is that they themselves are classes, and I'll cover that topic in the next slide. And so you have basically, this is where after that first line is pretty much the heart or the meat of your function. That's where you define what operations or what's going to occur. Once you define the function and then you carry out you write the code to carry out whatever operations you may or what have it be your function does, there's one very powerful keyword, and that's called return. So we could, if looking at this subtract function here, we could you see how it says return A minus B or return B minus A. What's going on there is that basically if the input parameter A is greater than B, it's going to return the subtraction value generated by subtracting A minus B, and vice versa with the else statement. If B is greater than A, then it will return the subtraction of B minus A. What's great about that is once you let's say that if we're looking where it says in out and in 9 on that picture, is if you said x equals subtract 3, 1, and you hit and then you were to carry out that operation, x would then be equal to either A minus B or B minus A. So what this really allows you to do is, you can write functions, or let's say that you have 10 lines of code that do a specific or particular thing. With a function, it's a nice clean way to take those 10 lines of code and throw them within a function. And it also provides you a way to, organize and help document give you some structure. I've been using Python for 5-6 years now. And when I first started out, I didn't use documentation, didn't really use functions, kind of just was rebel without a cause. And sometimes I go back and look at that code and it takes me 2 to 3 hours to figure out what all it was going on, because there was no comments, wasn't anything. But now I try to write functions as many times as possible, because it allows me to provide more, it's more readable. It's also a lot easier for you to pass it off to other people and for them to understand it. So with that being said, let's move on to the next topic, which is classes and objects. So one of the fundamental cornerstones of Python is, you may have heard the terminology of OOP, or object-oriented programming languages, thrown around. And what that essentially is, what a class is. A class is a way to store information. And then one of the great features about that is once you define a class, you can then copy all the contents of that class into an object. Now, I remember how I referenced objects earlier. This is where that they come into play. So big picture, a class consists of two parts. You have the header and the body. In the header, I should also denote that if you notice how underneath where it says class point, again, that has that first line, that again is the documentation string. So any little comment that you want to make to yourself or documentation as to like a little summary of what this class does, that's where you would provide it. So getting back to the two sections where there's the header and the body, the header usually consists of just one line of code, and it begins with the keyword class followed by the space and an arbitrary name. And again, the naming conventions for classes are the same that are used for functions. And again, those you can, if you're curious, you can find those in the PEP 8, which is basically the styling guide for Python. And it's usually followed by a listing of other class names of which the defined class inherits from. So again, if you think about the idea of a nested rushing doll, so you can have a multitude of other classes. And then let's say, you only want certain parts from those classes, like certain attributes or certain things found within them. You can call them within your own class when you define it. You just have to declare or basically let that class know where it's pulling that information from, so that you can then utilize whatever in that class is that you're wanting to get. And they're usually known as superclasses or base classes or parent classes. And again, that's a little bit beyond the topic of this discussion. So that covers the header section of a class. The next part is the body. This again is, if you notice where you say, class point and then the semicolon, you notice that right underneath that with the doc string, there's another indentation. And again, that I just now realized was something that I forgot to mention, and it's very vital. Python is very syntax oriented, and that means that there's a structure or a hierarchy on how things are laid out. So if you notice with the function in class, how there's always that indentation with it. And so if, let's say, for example, we had that doc string right under class point, and it was right under class and not shifted over like it is, and then we tried calling that class, Python would be like, spit back out, be like, nope, syntax error. And that's another great feature, and I'll discuss it further later on in this presentation, but the debugging capability, the ability to trace where a fault and error occurred. Again, going back to that nested Russian doll concept, you can have a lot of classes nested inside each other. And when you're trying to troubleshoot or backtrace, after you spend hours and hours on it, trying to figure out what's going wrong, that's another great feature of Python is it spits back out. It's like, well, you define your class, but then you call methods or other features from other classes, and here's where they're located, and this is what failed, and ... So when we're talking, so getting back to a body, remember that a class has two parts: a body, a head, and a body, just like a human. What goes on within the body is where you have objects and instant variables, objects, class variables, attributes, methods. So you might have heard me reference methods earlier. Methods are just a function. They're more versatile than a function, but the basic concept is, again, it's like a mathematical function. You have your inputs and you have your outputs. And most classes contain all classes have classes or have methods within them. And most classes have attributes. And now if you look at where that Juniper notebook session is, I made two classes. One class was called Killer Robot, and then the other, I believe, was called Non-Killer Robot. And if you look at the structure of how they're lined out, if you notice, there is a instance variable it's right below where the class name is defined. I cannot remember if I had a doc string, but underneath that, there's an attribute defined as, I think it's either name or status or something, and it should be equal to either killer or not killer robot. So if you look at the distinction between those two classes, what I was just talking about is called a instance variable. And so what an instance variable is if every time you call an object, so when I say call an object or initialize an object, if you see right where in the class is an object where it says in the presentation where it says q is equal to point, and then it has what's going on with that, what that does is that essentially transfers all of the content of what's in that class to that variable q. So you're assigning everything found within it. And so since we were talking about instance variables, what happens is, let's say you do q is equal to killer robot parenthesis, and then you hit shift enter. What's going to happen is if you notice that you can access that attribute by using a period. So you would say, let's say we set killer robot equal to an object of q. So it would be q dot the name of that attribute. I think it's either name or status. I'm drawing a blank right now because I don't have access to it. But what that means by when I say instance, that means that every time you copy over the contents of that class into an object, that variable will always be equal what it's set to. So that portion of that object is immutable. You can't change it. Now, speaking in terms of class variables are mutable. So once you copy the contents over of the class into the object and initialize it, you can redefine class variables all day. And then typically within classes, you have you have what's called that initialization, or the underscore int underscore. What that does is it's the default initialization method. So what happens is every time that you copy the contents of that information of that class into an object, whatever is in that block of code where the underscore int is, that is going to always happen when you copy or you initialize an instance of a class or an object from a class. Another thing is each class has its each own unique ID. So if you notice how it says q equals point ... Well, if you did ID q, then it's going to spit out a number. That's basically it's the way of tracking or finding where it's located within memory. Again, that's a little bit beyond the scope of this presentation. But then if you say you were to define, S equals killer robot, and then Q equals killer non-robot, and then you ran ID on both of them, the number would be different. One thing that's interesting, though, is if you define, let's say you say Q1, Q2, and you copy the contents or that class into that object, and you ran ID on them, I believe that they would be the same. And again, I covered documentation. So now we're going to move on to tying in the first section with the second section. So if you notice, all of those data types, they're all a form of a class. And what's really amazing by that is essentially all of that what's going on inside those classes. If you declare an integer, that class goes ahead and takes care of assignment. It takes care of a lot of overhead for you. Now this is really, really big. And these are functions right here, functions to help with classes. So if you're confused and you don't necessarily know all what's going on inside of a class and you want to peer inside of it, the DRI command it's a directory function. It basically gives you all of the attributes and methods within any class. So if you notice, I set specifically up where you could use these functions within that Jupyter notebook to peer inside, say, the integer class or the complex numbers class. And the directory function is very powerful. Another function that's very helpful when you're trying to troubleshoot or backtrace things is the get attribute function. So you know how if we named a class and we had a instance variable or an instance attribute, we could access that. We could get that information through using the get attribute function. Another great function is the has attribute function. It checks within the class to see if the attribute you're looking for is found. You also have the delete attribute functions, and then there's I would probably argue what is one of the most powerful functions built in to Python is the help function. And for those of you that have had direct Linux experience, and if you use the man command, which is short for manual, that's essentially the equivalent for Python. So you could do help and then the name of the object of the class. And what that's going to do is that's going to bring up all the documentation within the console for that specific class. So this is the last part, or let's take a break here, do a quick 5 minutes, and then move on to the last section. Are there any questions so far? Kind of use this time to play around with that Jupyter notebook and, kind of see if you can break that part of the section, or, try using the directory function, the dir function on any class, or try to get an attribute from an object that was copied over from a class, or, oh, yeah. And then, sorry, in addition to that, I just now saw that there were two of those that I left out on. Those were print. Print is essentially what allows you to print things to the console within a terminal. And then the type function tells you what data type or data structure the object is.
And Blake, it looks like I've got a question for you.
Sure, go ahead.
Can you review again the difference between an instance variable and a good old regular variable?
So so the difference between a variable and an instance variable is associated with classes, and they're defined within classes. They're usually immutable objects. So once you define a class oh, I'm sorry, could you repeat the question again?
Yeah, it's just the person is asking about the instance variable and why you need a class instead of just defining a function.
So the nice thing about a class gives you the ability to store more information than what just a function offers. You're able to have specific attributes or property values of a class, and you can then, the nice thing is you can then utilize those properties later on within the methods within the class. So essentially a class is a function on steroids with a lot more usability and features. And I think the question was the difference between a class variable and the variable. Variable is just when you're saying x equals such and such element, what that's doing is it's creating a object. Now where class variables differ from variables is class variables are only associated with classes. I mean, essentially they are the same concept or the same idea, but a class variable is attributed only to that class.
Any other questions?
If there aren't, then I think I'll go ahead and proceed.
Hi. Can, can you hear me or something?
Yeah, I can hear you.
Yeah, this is Candice. I have a question. So in the Jupyter, in the class
Mm-hmm.
that you create, you said like kind equals to killer robot,
Mm-hmm.
and that variable is an instance variable.
Correct.
Right?
Yes.
So you mean that within this class object, I cannot replace the kind variables with other things.
Right. So once
Okay.
you copy over the contents of that class into an object, which is also known as object initialization or object instance, that that attribute is always set equal to.
Okay. I see.
Yeah.
Okay. So because like if I am not in the class, I am just assigning a variable to something. I can always exchange it with other things, but in the
Yes.
class, I cannot exchange that with others.
Correct.
Okay. And another question is in the class object you wrote, you said like kind equals to killer robots, but
Mm-hmm.
where is this kind variable using? I cannot see in the.
I apologize about that. I was trying to off of memory reference that, but I goofed up on that one, so I apologize.
Oh, okay, that's fine because I'm a little confused about where is this variable using in this class object.
Did that help clear up your question?
Yes. And because in the following example you write something like x equals to killer robot self.
Right.
I'm not sure what's the self here.
So the self is that where it's where you see underscore int underscore?
Yes.
Okay, so what that's doing is anytime that initialization method takes two inputs, right?
Mm-hmm.
The first input is self,
Yes.
and then the next input is what?
Name.
Okay, so what happens is anything that's defined within that function or that method, the initialization method.
Mm-hmm.
So let's say you define or declare or set certain attributes and set them equal to values. Every time you say, if we go back to the killer robot class, when you say x equals killer robot parentheses,
Mm-hmm.
that initialization class kicks in every single time.
Okay.
So that's like an action. Think about it as an action, right? Every time that you create a object's instance, that initialization method is going on in the background. So if it sets specific attributes like the killer robot's height was 50 meters,
Mm-hmm.
it's always, then you could then go and once the class is initialized, you could access that attribute by saying x dot height of robot, and it would spit back the value associated with that attribute.
Okay.
See, it's very powerful because you're not having to do anything. It's automatic. It's a way of automatically guaranteeing that certain things are set when a class is initialized via an object.
Okay. Yeah.
Does that help?
I'm still not very sure about how class.
That's perfectly fine. Let's continue on with this.
Okay.
But keep that question in mind, and at the end of it, I would be more than willing to help you answer it.
Okay, sure. Thank you.
You're very welcome. Are there any other questions before I proceed?
No one else has added anything in the chat.
Okay. So this next section that I'm talking about is iteration. So if we remember where we talked about data types, structures, lists, these lists or these data structures, the dictionaries, the sets, the tuples, they essentially could consist of an infinite amount of elements. Really, the only limiting factor is the amount of RAM that you have on your computer. So iteration is a way for you to, instead of having to access by hand, let's say that you have a list and that list has 50 elements inside of it. And, you need to manipulate all of those elements, not all at once, but, you don't want to go by, let's say that you need to change them out. You don't want to go and, hit the name of the variable, square brackets, the index that's associated with it, set it equal to, the new element or value. this is where iteration is very powerful. So what we could do is we could set up a for loop that would essentially run the length or the number of elements contained in that list. And a very, very basic way to, let's say that you're using someone else's code, and we create an object from someone else's classes, and we don't, and some of the methods within those classes spit out lists of 50, and we don't necessarily really know like what's going on, or we want to like peer inside. A for loop is a really great way to check inside or deal with or carry out operations on that list with a minimal amount of effort. So for loops are traditionally used when you have a block of code in which you want to repeat a fixed number of times. Another way to iterate through the elements of a list or an object is the while loop. The key distinguishing factor between the for loop and the while loop is that if you're not careful with a while loop, it operates under a true or false condition. So you're basically say, while this certain value, until this certain value either is true or false, I'm going to keep iterating. This is where the term infinite loops comes into play. Usually they're caused either by a while loop or a couple of nested while loops. And those aren't really the funnest. That's not even a word. Those aren't the best way to it's a nightmare when you're troubleshooting that or debugging or trying to find bugs in your code. And then there's another way, which is called enumeration. Enumeration is a more advanced way of carrying out a for loop. It allows you to loop over something and have an automatic counter. So a for loop requires you to have a knowledge of how many elements are contained within that object itself. One nice thing is that there is a built-in Python function called len, which is just short for length. And what that does is if you utilize that function, that'll tell you how many elements are within an object. So the difference with the takeaway here is the difference between a for loop and enumeration is a for loop is you have to know the exact length or the number of elements in your object before you iterate it, versus an enumeration, because what happens is it uses some built-in Python functions that take care of not knowing how it removes the obstacle of having to know the amount of elements within an object. I will go into more detail about that in the next session next week, but that's beyond the scope of this talk. One great thing about Python, and I realize that I'm over, so I'm going to try to wrap this up as quickly as possible. But if you notice in those sections regarding file IO, so IO stands for input output. So one of the really nice things about Python is, how I referenced it earlier, is it kind of reads like in language. If you reference the Jupyter notebook and you see where it should be under the file IO section, you'll notice where it says, like, if you're wanting to read in a file, it says something as very simple as like F in, actually, I need to bring that up because that's so annoying. Essentially, what it allows you to do is it allows you to define classes. So take the file class and then define it as like F. And then you can refer to that file. And then when you define a file object, there are three methods within it: the read function, the open function, and the close function. And then there's also the feasibility of file output. So it's as easy as it is to read files in. It's also very easy to write data out to a file. And when you create an instance of a file output object, it has two methods in there, which is the .write and the close functions. And the write is what you think it does, is it allows you to write to that document or that file. One thing I heavily and very suggest that everyone does is whenever you're dealing with files and you're either opening them or writing to them, make sure that you always close them, because otherwise what you think is being written to that file is not, it's very hard to explain all the things that can go wrong if you don't close out of the file. Your data could be overwritten. It could be written to entirely another directory. I've had that happen to me, where I could not figure it out. So the read method requires the input directory of the file that you're trying to open. Basically, it's where the files are located. The open method it's what allows you to pass the directory of where the file is located, and then closes it. The write function is what allows you to write to that current file object. And the input is the string or the line that you want to be written. And again, you could utilize file input and output. One direct example or good use would be using the write function within a for loop. So if you have, like say a list and you want to save it to file, well then you could, here's some ways to do that. Another big thing about Python is its operators. It's arithmetic operators, it's comparison, assignment, logical, bitwise, membership, identity. Arithmetic is what you think it is. It's just it's what allows you to carry out mathematical operations. The comparison operator allows you to not only compare two objects to see if they're the same, but it also allows you to compare attributes or class instance variables within objects to see if they are in fact the same. And then assignment operators is again, is what allows you to modify or change a already defined object. Logical is, if you remember back in that very first function, which was the subtraction function, you notice how there was like what was called if and then or if and else. Those are known as logical operators. What those refer to is there's a condition that must be met. So for example, if my hair is blue, which is not true, then that would spit back a false. And so what you can usually do with operate with logical operators is you usually use it like if you need a either or option, or if you're using like a while loop and you're only looking for a specific value and you need to capture it, you can say if this element while you're iterating through that loop is equal to this value, then go and do this action. Bitwise is beyond the scope of this presentation, but it was a way for you to manipulate bytes and bits. The membership operator is a way for you to see if there is a specific element that's part of a list or a tuple or an object. And then the identity operator, the identity operator, sorry. The identity operator, I can't, hold on. The identity operator is basically allows you to see what is inside or not inside of an object. The membership is an operator that tells you what is or is not. So it's if a element is within a class or an object, it would spit back true. If it's not, it would spit back true as well. Then one very, 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 and this is the last thing that this is the last slide. It's called basically REPL. It's called read, evaluate, print, loop. And it's a form of writing pseudocode. So one thing that I heavily, heavily encourage everyone to do that is just start writing code is think about REPL is a plan, right? So when you're writing code, you just don't want to go all nilly-willy. You don't want to just start writing code without a purpose or a plan or an end goal. Think about REPL as a way of providing you an outline for, when you write papers. For me, myself included, I need an outline. Otherwise, that paper is going to be so horrendously written. REPL is the equivalent to that. And you save more time writing pseudocode or using a methodology like REPL than rather than just going and doing it off without a plan. It's a much more productive way to get results quicker. And then here's some resources that if you want to improve your or build upon what this presentation covered, these are some really good websites that are, you do not need to install Python locally. You can always go to these websites and they provide great documentation. And then when I was referring to the PEP 8 or the style guide, it's right under there under Python resources. And then there's the actual Python organization website itself. Here's some, if you were wanting to install Python locally, here is a hyperlink for that. And then if you were wanting to, if you were just absolutely riveted by Juniper Notebook and wanted to install it locally, that hyperlink right there shows you how to do it. And that will conclude the presentation. Are there any questions?
Okay, now's your chance. Any last questions?
Do you remember the name of the woman that had asked the questions about the class variable versus variable?
I think that was Candace.
Candace, are you still there?
Yes.
So I'm going to switch off of this and I'm going to, let's see here. Let's go, I'm going to bring up that actual instance itself and bring up and see if we can help clarify or let's see. Did I have a user? I don't know. We'll find out.
And while Blake is bringing that up, I want to thank you again for coming. And if you need to get going, we will be sending out some information to you, including the slides and information on our feedback form and additional information on part 2 of this series, which will be next week.
Okay. Let's see. So, killer robot, not killer robot. Where's that class section? So what was your exact question again?
So, for example, before you talk about the class, there's other function, right?
Mm-hmm.
For example, there's like the function like adding the numbers together.
Mm-hmm.
So can you show how can I put this function into the class?
So you notice how, like, if we go to where it says, so if you notice where it says define
Yes.
in the function,
Yes.
so what you would do is, like, let's say you wanted to modify not a killer robot. So what you would go to is where you see where it says class not a killer robot, parentheses, semicolon, and then it has the kind equals,
Yes.
and then underneath that it has def initialization.
Yeah.
What you could do is you could literally copy the entire function and then paste it right under the def initialization. And then what that would do is when you created an instance of that class by an object, you would then have direct access to that function. So let's say we called the function X, right? And we moved the subtraction function into that not a killer robot. You could access that method by, if we called the object X, you could access it by X.subtract. And then you could input your parameters and it would spit back out the subtraction of whichever number from the smaller number.
Hold on a second. So in the class of the not a killer robot, there's a self semicolon name. I can change the variable name of these two, or they must be self semicolon name.
No, they can. So if you, the only thing, like, so if you were to want to change it from being name,
Yeah.
the only thing that you would need to change is the name. So wherever you see where it says like self comma name,
Uh-huh.
if you wanted to change it to something else like Cobra,
Uh-huh.
wherever name was associated, you would just change name to Cobra.
Oh, okay. Nice. Yeah. One last question is, for the membership operator example, why for the last it says like print A in Y, why it is false?
Can you repeat that for me?
For the last at the bottom of the example, there's
Mhm.
there's an example like print A in Y, and the answer is false.
Print AY.
For the membership operator example,
Oh, which one?
the last one.
Those, oh, where it says print A isn't. So if you notice above, right? So variable Y is defined by so you notice how those are curly brackets?
Yeah, it's a dictionary, right?
Yeah, so it's a dictionary. So what it's doing is the membership is it's checking to see if the value A is in Y. But I think what is occurring right here is it's checking to see if the key A is in Y, not the value A, not the string A.
Oh, yeah, thank you. I guess that's all of my question.
Okay,
Thank you so much.
you're very welcome.
Hey, any other questions from the audience?
Thank you.
Thank you. And a side note is if anyone wants the, let's say that they've modified that Jupyter notebook and they want to keep the changes, just email me and I can happily give that file to you. There will be these slides and then the Jupyter notebook file used in this presentation available in my GitHub repo, and I'll get that out to all of you for anyone that wants it.
But we should email you if we want the Jupyter.
Correct.
Too. Okay, yeah, because I tried to download it and it said, no. It's read only. Okay, thank you.
You're very welcome.
Okay, last chance. No last minute questions? Okay. Well, thank you all for joining us. And again, look forward to some information in your email. And thanks for coming.
And don't forget that there's part 2 next week, same time.
That's right, same time.
And it will be a more advanced demonstration of what you can do with Python: data visualization, importing different packages, manipulating them, things like that.
All right, thank you, Blake, so much.
Thank you.